Welcome to Class Bridge, your bridge to clarity. I am Adinka Olonwa Adeboye, a math tutor. So if you are just seeing this channel for the first time, you can subscribe to this YouTube channel for videos like this. So this channel helps students to break down concepts that seems to be difficult to them in their classes. So how do we attempt this kind of problem? Laurent expansion. We are asked to expand f of z in a Laurent series valid for the absolute value of z greater than 1 and less than 3. So what is the approach? Looking at the function f of z, the function needs to be resolved into partial fraction. And how do we do that? Set this to be a, that is the idea of partial fraction, plus b over z plus 3. If you simplify this further, you have z plus 1 into z plus 3, a into z plus 3 plus b into z plus 1. Since the denominator are the same and they have equal sign, then this simply means that the numerator are as well equal. So it is safe to say that 1 is the same thing as a into z plus 3 plus b into z plus 1. Now, when you set the value of z to be minus 3, 1 will be the same thing as 0 plus 0 into b minus 3 plus 1, which will give us minus 2b, which implied as b is the same thing as minus 1 over 2. Let's do the same thing for the value of a. When you set x to be minus 1, 1 will be the same thing. We are still making use of this. So 1 will be the same thing as a into minus 1 plus 3 plus 0, simply because when you put minus 1 here, this part gives you 0. So now we have 1 equals 2a, which implies that a is equal to 1 over 2. Now that we know the value of a to be 1 over 2, let's substitute that into this expression. So a over z plus 1 plus b over z plus 3 is now the same thing as, since the value of a is 1 over 2, so we have 1 over 2 z plus 1 plus b is minus 1 over 2 over z plus 3. So now when you simplify further, 1 over 2 divided by z plus 1 gives you 1 over 2 times 1 over z plus 1. And this gives you 1 over 2 into z plus 1. So if you do the same thing for the other term, you get 1 over 2 into z plus 1 minus 1 over 2 into z plus 3. Now that you have this part, this is the same thing as 1 over z plus 1, z plus 3. Now that we have resolved the given question, which is f of z, into partial fraction, then what do we do next? Now, from the question, it is given that 1 is less than the absolute value of z less than 3. Now, this simply means that the absolute value of z is greater than 1, and also the absolute value of x is less than 3. That is the interpretation of what is given. So in this case, you begin with if z, that is the absolute value of z, is greater than 1, and then you pick this part of the expression, 1 over, which means that you are dealing with 1 over 2 into z plus 1. So if you simplify this further, now you need to take note of something. Whenever you are dealing with greater than, at this denominator point, you factor out z. But if you are dealing with less than, you factor out the constant. Let me take that again. If you are dealing with greater than, you factor out z. But if you are dealing with less than, you factor out the constant, that is 1 or whatever the number may be. Now, let's factor out z since we are dealing with greater than. And that means we'll be having 1 over 2 z into, do not forget that if you have something like this, 6x plus 3, and you ask to factorize, you look at it and say, what is common? And you ask yourself, what is common between 6x plus and 3? And then you say 3. How do you now generate the numbers inside this part? You say that 6x divided by 3 that is common, which gives you 2x, plus 3 divided by 3, which gives you 1. The same thing is applicable here. Since you are going to be factoring out z from z plus 1, then you write out your z, and you say z divided by z, which is 1, plus 1 divided by z, which is 1 over z. So now in this case, you'll be having 1 over 2z into 1 plus 1 over z. Now, this is what we are working with. So how do you now expand this in form of Taylor series? So let's do that. 1 over 2z into 1 plus 1 over z is the same thing as 1 over 2z times 1 over 1 plus 1 over z. Now that we have this part can be expressed as a Taylor series. How do we do that? 1 over 1 plus 1 over z. Let's set our z, 1 over z, to be u. If 1 over z equals u, then I want to deal with f of u, which is 1 over 1 plus u. This is what I want to deal with. Although this is what I want to express as Taylor series, but I'm converting it to u. Why? Because dealing with 1 over z directly might not end up well. So let's do it this way. Now, if I have 1 over 1 plus u, that is the same thing as saying 1 plus u to the power of minus 1 indices. Now, don't forget the Taylor series. Don't forget the Taylor series. N equals 0 to infinity. Then we have fn of 0 as a Maclaurin to u to the power of n. Don't forget we are dealing with u. So this is what we'll be using. So now we have f prime of u. If you differentiate this, you have minus 1 plus u to the power of minus 2. If you differentiate further, you have 2 into 1 plus u to the power of 3. If you differentiate again, you have minus 6 into 1 plus u to the power of 4. And if you do that one more time, you are still going to get something meaningful. So now let's slot in the value of 0. When f of u is 0, what do you get? At a equals 0, this will definitely give us 1, because when u is 0, we have 1 over 1, which is 1. When u, this is the same thing as saying minus 1 over 1 plus u to the power of 2. So when u is 0, you get minus 1. And for this, when u is 0, you get 2. Also here, when u is 0, you get minus 6. Now, using this Taylor series or Taylor expansion, substitute the value of u and the value of fn of 0. So you have the first one, which is when n is equal to 0, is the same thing as saying 1 over 0 factorial times u to the power of 0 plus, that should be minus, because of this, minus 1 over 1 factorial u to the power of 1 plus 2. This now plus 2 over 2 factorial u to the power of 2 plus, as minus 6 over 3 factorial u to the power of 3. And when you simplify this further, this will give you 1 minus u plus u squared minus u to the power of 3. Do not forget that u is the same thing as 1 over z. Then you substitute to get 1 minus 1 over z plus 1 over z to the power of 2 minus 1 over z to the power of 3. And this gives us 1 minus 1 over z plus 1 over z to the power of 2 minus 1 over z to the power of 3 plus, and so on. Now that we have the expansion of this term, then we can now easily substitute into the question. So now this simply means that we have 1 over 2z into 1 minus 1 over z plus 1 over z squared minus 1 over z to the power of 3 plus. So now you can open the bracket. So you have 1 over 2z into 1 minus 1 over z plus 1 over z squared minus 1 over z cubed plus, and then when you do that, you have 1 over 2z minus 1 over 2z squared plus 1 over 2z cubed minus 1 over 2z4 plus. Now for the second aspect of the question, at where the absolute value of z is less than 3, we are considering 1 over 2 into z plus 3. That is the second part here. We are considering the second part. So now this gives us, don't forget I made mention of something earlier. I said if you are dealing with less than, you factor the constant. But when you are dealing with greater than, you factor z. So in this case now, we are dealing with less than. So we factor 3, which is the constant there. So that will be 1 over 6. That's 3. When you bring 3 outside, it multiplies 2, and you get 6 into z over 3 plus 1. So this is what you have next. Then when you are to, what are you going to expand into Taylor series? You are expanding 1 over z over 3 plus 1. So do this same thing using Taylor series. You can pause the video to do that. Now, this is what you get. So if your answer is not the same with this, you can try again. So now the next step is 1 over 6. You open the bracket with 1 over 6, and that gives you z over 18 plus z squared over 54 minus z cubed over 162, and so on and so on. So this is the result you get. Now, this is not yet our final answer. Do not forget these inequality were combined. So to get your final result, you have to combine the first term that we simplified together with the second term that we simplified. What does that mean? The point at which the absolute value of z is greater than 1, you combine it with the point where the absolute value of z is less than 3, which we just concluded. And what would be our final result? So now this is our final result. At 1 is less than the absolute value of z less than 3. So if you find this video helpful, click the subscribe button to get more related videos like this. And do not forget to try this and drop your answer or your final answer in the comment box. See you in my next video.